Hi friends, welcome back to our channel Easy Mathematics. Today we are going to discuss a very important topic in mathematics. So throughout mathematics we use this term, that is functions. So today we are going to discuss about functions. So first, what is function? How we can define a function in mathematics? So function we can define from a set to another set. So function means basically it is a mapping. So different ways we can represent a function, isn't it? So in set theory we already discussed different representation of set, isn't it? Raster form, set builder form. So in mathematics, how we define a function, how we can define a function and how we can denote a function, that is very important. So a function is a mapping from a set to another set. So function means it is actually a mapping of two different sets. So if f is a function from a to b, we usually denote it as So if f is a function from a to b, we denote it as like this. So we read it as f is a function from a to b. So this is the notation that we use to represent a function. So if a function f we define from a to b, we denote it like this. Okay, so this is the notation corresponding to a function from a to b. We can easily understand a function using arrow diagram method. So in arrow diagram method we can represent a function only if the two sets a and b are finite. So in a finite set we can represent that function using arrow diagram method. F be a function from a to b. F is a function defined from a set a to a set b. So we are going to represent that function using arrow diagram method. Arrow diagram method representation will be always like this. So f from a to b is the function. So a and b are two finite sets. A contains three elements x1, x2, x3, and b contains three elements y1, y2, y3. So how we define a function? This a is called domain of the function, isn't it? B is called codomain. So from which set we are defining a function, that set is called the domain of the function. To which set we are defining, that set is called codomain of the function. So here f is a function from a to b means a is domain of the function f and b is the codomain of the function f. So same manner, if f is defined from x to y, then set x is called domain, y is called codomain. So here a is the domain, b is the codomain. So a and b, domain and codomain of this function f, contains three elements each. So I'm going to define a map from the set like this. So this arrow implies image of x1 is y1 under this function f. So x1 its image is y1, x2 its image is y3, x3 its image is y2. So this arrow represents this x1 is mapped to y1. Image of x1 is y1. And in function notation we can represent it like this. F of x1 is equal to y1. So meaning of this one is image of x1 under this function f is y1. So this arrow implies image. So x2 its image is y3. Then how we can represent f of x2 is equal to y3. Then x3 its image is y2. So we can represent it as f of x3 is equal to y2. So this is how we denote a function. Then what is a function? So is this mapping? So this is a mapping. We want to check whether this mapping is a function or not. So this mapping becomes a function when it satisfies certain conditions. What are the conditions? So here we said this A is called domain, B is called codomain. Then this mapping becomes a function if every element in domain. So this is the definition of function. So listen carefully. Every element in domain must have one image. So every element in domain, if every element in domain has unique image, one and only one image. Unique means one and only one image. So x1 must have one image, unique image. So that is x1 image is y1. No other images there for this x1. So x2 image is y3. No other images are there. Then x3. What is image of x3? y2 is the image of x3. So every element in domain, if images, unique images exist, such mappings are called function. So here what are the elements in domain? x1, x2, x3. Every element in domain has unique images, isn't it? One and only one image. x1 has one and only one image, y2. x2 has one and only one image, that is y3. x3 has one and only one image, that is y2. So different elements, every elements in domain has unique image. Such mappings are called functions. So this mapping is an example for a function. For example, let g be a function from x to y. So I am defining a mapping g from x to y. So x is called the domain, y is called the codomain. We want to check whether this mapping is a function or not, and I am going to define this function g using arrow diagram method. So x contains 4 elements, a1, a2, a3, a4. Y contains 3 elements, b1, b2, b3. Okay, then I am defining this mapping like this. Then what about this g? So we define g using arrow diagram method like this. So g is a function from, g is a mapping from, not function. We want to check whether it is a function or not. So now it is g is a mapping. So g is a mapping from x to y. Mapping is defined like this. So a1 mapped to b1. So image of a1 is b1. a2 image is b1. a2 has one more image, b3. Then a3 has one image, b2. a4 has one image, b2. Then what about this mapping, whether it is a function or not? So what is our definition of function? What is how we define a function? A mapping becomes a function if every element in domain must have unique image, isn't it? So if every element in domain must have unique image, then we can say that mapping as a function, isn't it? So here a1 has one and only one image, unique image should be there, isn't it? a1 has one and only one image, that is b1. Then what about a2? a2 has 2 different images, so it contradicts our definition. Every element in domain should have unique image. So here the a2 has 2 images, so it contradicts our definition, so it is not a function. But a3 has image b2, a4 also has image b2, but it is not a contradiction for our definition. Why? Because a3 has one and only one image, that is b2. Image may be same, But A3 has one and only one image B2. A4 also has one and only one image, that is B2. So that is not a contradiction to our definition. What is contradiction to our definition? One element, two images. That is contradiction to our definition. So this is only a mapping, or we can call this mapping as a relation from x to y, but it is not a function.